Welcome back to The Explainer. Today, we're tearing down a major myth that frankly haunts dashboards, spreadsheets, and corporate boardrooms everywhere. We're unpacking a really bold claim drawn straight from Ibrahim's incredible visual guide, and it goes like this. Clean code does not always produce correct conclusions. I mean, you can have the most elegant Python script in the world, the most beautifully structured SQL query, or a spreadsheet with literally zero formula errors. But if your foundational thinking is flawed, well, your results are going to be absolutely flawed too. Okay, let's dive into this. The entire foundation of what we're talking about today rests on this single, super powerful quote. A technically correct analysis can still lead to the wrong decision. This is a massive paradigm shift for a lot of us, right? We're so heavily conditioned to think that if the math adds up and the code runs without throwing any big red error messages, we've automatically found the absolute truth. But data analysis isn't just about calculating numbers. It's about accurately interpreting reality. If your inputs, your context, or your assumptions are detached from the real world, your flawless calculations are just going to confidently point you in the completely wrong direction. To navigate this whole landscape, we're using this fantastic infographic by Ibrahim as our roadmap today. It masterfully maps out the 7 mistakes that can ruin your data analysis. I absolutely love how this visualizes what I like to call the illusion of analytical perfection. We're going to use this roadmap to explore every single pothole and trapdoor in the lifecycle of a data project, starting from the very first question you ask, all the way to how you present your final charts to the decision makers. So, here is the structured journey we'll be taking today. First, building on flawed foundations. Second, misinterpreting the metrics. Third, presenting without limitations. And finally, AI versus human judgment. Let's kick things off with phase 1, building on flawed foundations. This crucial preparation phase is honestly where the first 3 critical mistakes hide in plain sight, way before you even write a single line of code. Mistake number 1 starts before you even touch a dataset. You have to ask yourself, what is your actual business problem? I've seen so many incredibly talented analysts fall right into this trap. You can analyze a mountain of data, build highly complex machine learning models, and generate 50 stunning visualizations without actually solving the core business problem you set out to tackle in the first place. You might be answering a question beautifully, but is it the right question? If the business needs to know why customer churn is spiking and your analysis focuses entirely on the demographics of new acquisitions, you've completely missed the mark, no matter how pristine the underlying data looks. Let's move to mistake number 2. And this brilliantly illustrates the danger of just taking data at face value, ignoring missing values. Notice how the profit data for the South region here is just a dash, and the sales data for the East is just missing entirely. If you blindly run an average or throw a trend line through this dataset without actively addressing those gaps, you are severely distorting your results. I mean, did the South actually make zero profit, or did the reporting system just glitch out and fail to record it? Ignoring missing values or lazily assuming they just equal 0 is going to drastically skew your models and give you completely false business insights. Mistake number 3 is a total classic for anyone looking for clean data, and that's automatic outlier removal. Now, an outlier is simply an unusual value that sits way outside the normal range of your dataset. The temptation is always to write a quick script that automatically deletes anything outside of a standard deviation just to make your charts look pretty and your trend lines perfectly smooth. But here's the massive danger with that. That unusual value might be a simple data entry error, sure, but it could also be an incredibly important business event. What if that huge spike in sales was the result of a wildly successful viral marketing campaign? If you automatically delete it as an error, you literally erase the exact insight you need to replicate that success. You've got to investigate your outliers, not just exterminate them. All right, moving on to phase 2, misinterpreting the metrics. This is where we actually start crunching the numbers, and it's exactly where mistakes 4, 5, and 6 can completely derail your logic. Mistake number 4 is probably my favorite because it's just so common. Confusing correlation with causation. Take a look at these 2 ideas side by side. Ice cream sales and drowning incidents. They move exactly together. When one goes up, the other goes up. They're perfectly correlated. But does that mean eating ice cream causes drowning, or that nearly drowning makes people crave a vanilla cone? No way, right? That's absurd. The hidden variable here, the actual cause, is just summer heat. When it's hot outside, people eat more ice cream, and people go swimming more often, which tragically leads to more drownings. Just because 2 variables move together does for sure not prove that one caused the other. You always have to look for that hidden driver. And see how this builds into mistake number 5, using the wrong metric. Take a highly impressive metric like 95% accuracy. It looks fantastic on a slide deck, doesn't it? But naked metrics like 95% accuracy, or a $120 average, or a 2% conversion rate, they are completely misleading when used without context. For example, if you're building a predictive model to detect a rare manufacturing defect that only happens, say, 1% of the time, a totally lazy model that just guesses no defect every single time will literally be 99% accurate. It sounds great. Actually, it sounds perfect, but it's 100% useless for actually catching the problem. You have to ensure the metric you're celebrating actually measures success for your specific scenario. Which brings us to mistake number 6, ignoring data leakage. This one is a little bit more technical, but it's incredibly destructive. Data leakage usually happens in 2 steps. Step 1, information from the future, or from your test dataset, accidentally leaks into the data you're using to train your model. Step 2, because the model has essentially seen the answers before taking the final test, it appears artificially better than it really is. It's exactly like giving a student the exam answer key the night before the big test. When you deploy that falsely optimistic model out into the real world with truly unseen data, it's gonna fail miserably.
Now for phase 3, presenting without limitations.
This is that crucial moment where your analysis leaves the safety of the data team and meets the real-world business stakeholders. Mistake number 7 is handing over a pristine, beautiful report without acknowledging what you don't know. Every single report summary absolutely must include these 3 things: assumptions, uncertainty, and boundaries. Pretending an analysis has no limitations is a massive trap. Look, if your model assumed inflation would stay flat, you must state that assumption. If there's a 10% margin of error in your survey, visualize that uncertainty. If the data only applies to the North American market and not Europe, clearly define those boundaries. If you don't communicate these limits, stakeholders will just treat your estimates as absolute, ironclad guarantees, and that is a total recipe for disaster. Finally, phase 4. AI versus human judgment. In today's landscape, we simply cannot talk about data analysis without talking about artificial intelligence. First off, let's validate exactly what these tools can do, because it's undeniable that AI is incredible at the technical heavy lifting. AI can write the code, it can calculate the complex metrics, and it can generate the charts in mere seconds. What used to take a junior analyst 3 days of just staring at documentation can now be drafted in a single well-crafted prompt. It's a massive, game-changing accelerator for the mechanical parts of data work. So the crucial point is understanding exactly where AI falls short, because it has major blind spots. It might not know whether the historical data set you fed it is inherently biased against a certain demographic. It doesn't know if the mathematical metric it perfectly calculated actually fits the nuanced business problem you're trying to solve. It doesn't have the real-world context to know whether a massive outlier is just a system glitch to be removed or a Black Friday sales record that needs to be deeply studied. And perhaps most importantly, it might not realize that the statistically sound conclusion it just generated is highly misleading when applied to messy human behavior. AI just lacks lived experience and business context. Which leads us to the ultimate culmination of this entire explainer. AI accelerates analysis, but human judgment protects its quality. You are not being replaced by AI. Your role is just shifting. You're becoming the editor, the context provider, and the ultimate guardian of quality. You can, and absolutely should, let the machine do the raw speed calculations, but you must rely on your human judgment to ensure the output actually makes logical sense for your business and avoids the 7 mistakes we just covered. I want to leave you with this final provocative thought. Next time you look at a flawless, beautiful chart on a dashboard, will you just blindly trust the code, or will you actively question the context? Remember, analytical perfection is just an illusion if the foundations are weak. Don't just be a passive consumer of data. Be a critical thinker. Thank you so much for joining me on this explainer, and I really hope this empowers you to spot these mistakes before they can ruin your next big project. Keep learning, keep questioning, and I'll catch you on the next one.